Hello everyone, this is Mustafa. In this lecture we're going to talk about how to create a SD card image so that we can boot our Raspberry Pi. So first, I'd like to say that the boot has been successfully completed. In the last lecture, what we did was we set up the UART and we installed some SSH server, and then what we did was we executed this command and it was successful, and now we can start simply checking what are our outputs. Alright, so first thing first, let me remind you this boot flow, right? We have already seen something similar. We had this boot flow where we had the power up, then comes the bootloader stage, and then it is simply initializing the CPU memory storage, maybe also loading the GPU firmware, then reading these cmd.txt and config.txt files and passing those parameters to the Linux kernel and executes the kernel from the RAM. Then the Linux kernel starts the operation. For Linux kernel, we have this image file that we are going to look out for. This is the kernel image, and then at some point the device tree blob will be loaded, and also device tree overlays will be loaded, and drivers will be loaded based on these device tree blobs, and then it will mount some initial RAM disk. This is simply to find the real location of the rootfs during this Linux kernel initialization, and then will come the actual rootfs mounting, and then init program or init software will be started. Then we are in the user space. The reason I showed you this because we would like to see these also in the image outputs. I just wanted to let you know that okay, we are looking out for these files. Where are they? In the SD card. And for the bootloader, we had some files that we are not changing anything for now. We had the uboot binary, but for the Raspberry Pi 5 currently you won't be seeing these because there is no uboot support at the moment. We'll just be seeing these basic bootloader files. Alright, so let's go back to our shell and let's try to find this. As you recall, we have already described where these deployed image files will be located at, and it was under build tmp deploy images, and here we have the machine name, and inside, as you can see, we see many files. These are all the outputs from the image build, basically. In order not to confuse ourselves, let me first start by saying that you will see a lot of device overlay files that are compiled, all these DTBO files, right? These are all for different modules, and just don't confuse yourself with that at the moment. This is the, let's say, default behavior of this Meta Raspberry Pi, that it is basically building all these device overlay modules, and it is not using them. Alright, so let's then start from the beginning. What we have, okay, we have the device tree overlay files, and we have the actual device tree file that is compiled, which is important. We will see this in our boot partition. When we create SD card image, then we have a folder called boot files. If we go inside, we will see all things related to the bootloader simply, and our cmd.txt and config.txt. So these are the basically final outputs before we simply deploy everything to the SD card and run it, right? So you can even check these files in order to see everything is correctly configured, for example. As you can see, we did this work already, enabling the UART, so everything looks to be in place. If we continue, we see our main rootfs. Here, as you can see, with the X3 extension, then we can see the actual file with the WIC, compressed WIC format that we will be flashing to our SD card. Then you can see some symbolic links to these actual ones. These files are created with some timestamp, and these are actual symbolic links that are pointing to these created files, basically. And we have the DTBO files, we have the kernel image. As you can see, this is simply symbolic link that is directing to this one, or showing linking to this one rather. And let's go down, and there's nothing else. So what we have seen already in our outputs, we have seen these we didn't see any U-boot as expected because it's not included in the Meta Raspberry Pi layer for the Raspberry Pi 5 only. If you take a build for the Raspberry Pi 4, it is included on demand. We have seen these two, we have seen the image, we have seen the device tree, we have seen the rootfs. We haven't seen the initial RAM disk as a separate, but maybe this is embedded in another image. Alright, that's all good. So now what we can do is we can simply learn how to create a SD card image. For that I'm using some tool called Balena Etcher. Let's try to find it online. So you simply type in Balena Etcher here and you can download it. I have already downloaded it, but you can simply click this button in order to download the tool. And you have basically some options. You have the app image that you can simply run directly. Let's download it. And after download, let me show you what you will get. You'll get something like this, some file like this. This is probably one of the earlier versions, but I don't want to replace it. So after you get this, simply copy the name and make sure that it is executable by executing this command, and then you can simply run this. Once you run this, you will be welcomed with this tool, and it's really easy to use tool. Let's say first make sure that you have your SD card. Let's say mounted in your host PC, in your development PC. As you can see, it is already mounted. In my case, this boot and root, and it already has an image, but I will simply overwrite this one in order to show you. Then simply click Flash from File, and from this, what you will need to do is you will need to locate the image I told you about. The image I told you about was this WIG file, compressed WIG file. So just locate your Pocky directory and build tmp deploy images, machine name Raspberry Pi 5, and then you have all these options that you can simply flash. What you would like to do, what you would like to select is this one. In this case, you can simply double click, which involves all the other images I told you about, including the rootfs. Then click to select the target, your SD card reader. In this case, I have way too many space for my SD card, so it can be something like 16 GB would do for us. And then simply click Flash, and since it is a large drive, it's letting me know that it is too large. Do you want to erase it? I said yes. First it will decompress and it will simply erase the disk. Then it will simply flash and do some validation, do some verification on top. This will take quite short amount of time because didn't include any display server or anything. It's just some basic image that is supported by the Raspberry Pi 5, and that has console support. So now the flash has been completed, and after the flash you can simply check this SD card has two partitions because we have created this image in that way, and this is the default behavior for the Pocky. So you have the root partition and the boot partition. Boot partition contains all the things regarding the bootloader stuff, kernel stuff, and then you will be simply running this root of it. You will be mounting it, and then from inside this you will be running the init file. If I can find it, I can maybe show you. Is it here? Or yeah, this one will be the first program that will be executed on this root partition basically. And if we go back, we can notice some differences. For example, the kernel image has some different name in our case, and then yeah, you can find the DTBO files here. And if you recall, we have added this UART0 Pi 5 device tree overlay in our local conf, in our Raspberry Pi config bb-append file, so that this is compiled and deployed, and in fact we can see this change. Alright, so after this, simply close the Balena Etcher program and navigate to your Poki directory. Okay, and then one thing we need to do is simply set up Serial Console in our development PC. For this, what you can do is simply install Minicom. Throughout this course, I will be using the Minicom. In order to install it, simply type in sudo apt-get install Minicom. Since I have already installed it, it didn't do anything for me, but then you'll have this Minicom binary that you can use to set up. So let's go ahead and do that. The way to use it with the setup is sudo Minicom, and that's it actually. And while we're at it, let's add this command to our documentation real fast, not to forget it. Serial and we can also add cooking image recipe. And for this cooking, I sometimes use this it's baking. And for this, we had already used this core image minimal. Okay, so let's do some setup. Before executing this, let's check which serial port is available for us. So for that, I will be simply checking the created device files by using this command. This command will give me the available ports, and you will see that okay, there is one serial adapter connected, which is called TTI USB 0. The way you can simply identify this is you can execute this command before you plug in the USB to UART connector, USB to UART adapter rather, and then you can do the same with the USB UART converter simply plugged in. So let me plug it out just to show you. I plugged it out, I executed the command, and this is not visible, and then I'm plugging it in, and after I plug it in, I will see this adapter. Okay, so now we know the name in our development PC, the name of the serial console. Now we can type in sudo minicom s, and simply we can go to serial port setup, and for serial device you have to click A first in order to select this portion, and you enter this, and to be able to set up the baud rate, if it's different in your case, you go you first press enter, then you type in E, and then you can click E again in order to set up the baud rate as this one. So I click E and I pressed enter, then everything is set up correctly. I don't need to change anything else. You rarely have to change anything else, to be honest. And then I click enter and exit, and now I have my serial console setup for the development PC. Now what I can do is I can simply plug the Raspberry Pi with the USB connector, with the USB power, and I can see the board booting. Hopefully we will check. So as I am speaking, I have just plugged it in. As you can see, we don't have a bootloader output at the moment to this specific serial, but I am expecting some kernel messages, hopefully. Let's see if we get to that, or if we had made any mistake, we can correct it later. Forgot to pull the SD card in, sorry. Let me try this one more time. Okay, now the SD card is in and the board is plugged. Let's check it again. Okay, as you can see, the kernel is booting at the moment, and then this init process has been started at this stage. So at this stage we are simply going to the user space mode, and user space applications are loaded after this one. And yeah, at the very top you can see the start of the kernel boot. That's really good to identify, and once everything is done, simply a TTI terminal will be available for us. This console will be available, so we can enter our credentials, and we can start to experiment with the actual distro that we just created. So the credentials for the Raspberry Pi 5 login is simply root. We don't have any user, we just have root, and root has no password. Of course, this is really insecure. The POCI lets us know that this is used for only testing and development purposes, and we should be simply customizing this. We should be adding new user, and we should be considering all the sandboxing approach for the security later on. Alright, so once we have this terminal, it's really good thing to see. Everything has booted up. We can check dmask for any errors in order to continue with our board bring up, but since the folks that are developing this Meta Raspberry Pi 4, Meta Raspberry Pi Lear, and also the Linux kernel maintainers for the Raspberry Pi has put significant effort into this, we don't expect anything weird at this stage. We don't expect any blocking kernel error. There could be some issues, minor issues. Of course, this is open source, but we are almost good. Okay, so on top of this, one more thing that we can do in order to edit some text files inside the board, we can install simply some text editor inside our distro, right? Because we don't have that option yet. If I type in nano, there's nothing. If I type in, oh, there's V. Okay, but I'm not familiar with V, so I'm gonna have to install nano. If you are familiar with the Vi, then you are lucky, but I didn't use that before, so I'm gonna simply go to my local conf, and by just entering one line I can install this, I can deploy this to my SD card. That particular line is image install append nano. You just don't forget the spaces. This one is mandatory, this one I always leave it, but it's up to you, to be honest. And also I'd like to let you know that we are doing all modifications here, but it shouldn't be this way at the end. It should be more structured, so we will tackle this when we have our layer more properly set up. We will simply move these into our layer. So in order to complete this Bitbait Nano deployment, we can simply take another image. Actually, let's run it with the G option first to check if Nano will be indeed built. Then we can do the actual image build. Okay, so it has been completed. I can simply copy this file name and I can open it in my Visual Studio Code. And I can search for the name Nano, but I have immediately seen it, so indeed this is gonna be built. So let's go ahead and do our build, and let us add this video. Of course, you're gonna have to repeat this SD card installation, and you don't have to do it always. Let's say you can simply take the Nano binary and simply copy it to the proper location by using scopy, by using SSH connection, and you can avoid this image build. But for the sake of simplicity, for the beginning, we're gonna do this. And there's also one thing that I forgot to mention. So how to access this board using actually the SSH client, right? We have accessed it by using the serial terminal, but we should also do it with the SSH just in case we need it. It is faster after all than the serial. So what you should do is first you can gather, you should know the IP address of the Raspberry Pi, right? Because our development PC and the Raspberry Pi is connected to the same network at the moment. There are two methods to identify the Raspberry Pi IP address. First method is, since we have already the serial set up, we can simply check from serial. So let me boot the board. Okay, the board is booting at the moment. and I have the login. I type in root and I am inside. Now I can type in ifconfig, and it immediately tells me the IP address of this kernel network interface. Alright, so I know the IP address now. Now I can simply SSH into it. But I'm gonna also cover a method to learn the Raspberry Pi IP address in case you don't have access to the serial just yet. So what you can do, exit this one, and you go, we will use nmap. This is simply an IP scanner tool. So sudo nmap -sn, and you go with your network /24, your net mask, and it will do an IP scan, and it will give you all the IP addresses that are available to communicate in your network. In this case, we already know our Raspberry Pi is this address, but you can simply check all the IP addresses here. So for example, I can try to check this one. In order to check it, simply SSH root at IP address, and if I don't have a response for a couple of seconds, I can immediately abort. This means that I cannot access it simply. Second one was this one. I'm gonna go SSH root at this IP address. Then there's this warning regarding the security. I have to copy this command. In case you get this warning, you also have to do this. Copy this and paste it. Then simply root SSH into your machine again and enter yes, and we are inside the board using the SSH protocol. Okay. For this video, I think this was all I wanted to mention. Thank you very much for your attention, and I will hear you next lecture.